Okay, so today I'm going to show you how to find the area of a region bounded by two curves. So the two curves that we're given in this problem are the graphs of the equations y equals x cubed and y equals 4x. So we're going to start by sketching those graphs. Y equals 4x is going to be a line through the origin. Something like this. And then y equals x cubed has this essential shape. Okay, and now we've cut the plane up into a bunch of different regions, and the only part which is bounded, the part that has finite area, is what I'm going to shade in here. So now we've defined a region, and we'd like to compute its area. Well, the first thing that one can note here, if you can spot it, is that there's some symmetry. The area of the right half and the left half are the same. So if I just want to focus on this portion of the region, I can double its area. Now, what do we need to do? Well, we're going to chop this up into a bunch of little vertical line segments. One for each value of x. That's actually in the region. And I'm going to label the endpoints of this vertical line segment based on what curve the bottom and the top point are on. Well, let's see, the blue curve is y equal 4x. And the black curve is y equal x cubed. So if I call the x-coordinate of this bottom point x, its y-coordinate is going to be x cubed. And similarly on the top, the x-coordinate's x, the y-coordinate's going to be 4x. Okay? Now the length of this vertical line segment has a function of x. That's going to be what? 4x minus x cubed. Right? Because you subtract the y-coordinates of the top and the bottom point. Now, what we're going to do is kind of think of this vertical line segment as being a rectangle with this length and with width dx. Okay? So the area of this rectangle would be 4x minus x cubed times dx. Now, how many of these do we have? Well, you can see that there are a lot of vertical line segments that enter the region. I need to know for which values of x I actually have a vertical line segment that enters the region. And it's going to be for every value of x between the x-coordinates of these 2 points here. Now, you might be able to eyeball this one and tell me it's 0, 0. This one might be a little harder to do just by eyeballing it, but we can use some algebra to find the x-coordinates of these 2 points. So to get the x-coordinates of the points of intersection, we're going to solve x cubed equals 4x for x. So let's go ahead and proceed. That becomes x cubed minus 4x equals 0. That's x times x squared minus 4 equals 0. X times x minus 2 times x plus 2 equals 0. And we get 3 solutions. X is 0, 2, or negative 2, which really corresponds to actually the 3 different points of intersection that we have on this curve. Now, as we noted earlier, we're just going to take the area of the right half and double it. So it should be clear now that if the 3 coordinates are 0, 2, and negative 2, that this one's 0, and this one up here is 2. So how many vertical line segments do we have in the region? We have 1 for every value of x between 0 and 2. We're going to use the integral to add them all up. S for sum. The 0 and the 2 here are indicating that we're only going to be adding these up for x values between 0 and 2. And we'll try to get the area of the region, so this is what we're going to add up. 4x minus x cubed times dx. Now solving this is what we just did in the previous chapter in the book. So let's just go ahead and knock this thing out. Took my antiderivatives of 4x and x to the third respectively. We're going to evaluate 2, so we plug 2 in for x. 2 squared is 4, times 2 is 8. 2 to the 4th is 16, divided by 4 is 4, minus what we get when we plug in 0. Well, 0 is a friendly number here, 0 minus 0. And it would appear that the answer is 4. Now this is just for the right half. This is the area of the right half. The total area technically would be the integral from negative 2 to 2 of 4x minus x to the third dx. But as we noted earlier from symmetry, this is double the integral from 0 to 2 of 4x minus x to the third dx, which we just computed to be 4, so 2 times 4 equals 8.